In the last part of this lecture, we'll go into chemical and physical properties of biomass. We will have a look on contents of moisture, ash, and combustible substance. And we will have a look on density and heating calorific value. So the composition of biomass or biofuel. It consists of combustible substances, which is volatiles and char, ash, and moisture. And these components are measured in mass percentage of fuel. And the amount of these different compounds vary, of course, depending on which kind of biomass or biofuel that you are studying. If you don't include moisture, you only have the dry substance, and the combustible substance are only the volatiles and the char. And it is also often defined as moisture and ash-free. The amount of moisture vary in different biomasses. On this slide you can see that in raw woody biomass from the forest, it is around 50%, 40 to 60%. And if you dry it, of course you decrease the moisture. You can decrease it down to 10 to 15%. When you have pellets, for example, the moisture content in the pellets are around 8 to 10%. Straw has a lower moisture content compared to forestry biomass, only around 15%. Raw peat can have moisture content up to 90%. But when you harvest the peat, you put it on the land for a while for drying, for decreasing the moisture content. Municipal waste can have an average moisture content of 30 to 40%, which is related to the organic waste then mainly. The different compounds of ash are silicon, aluminium, iron, and calcium. Those are the inorganic parts, minerals in the biomass, biofuel. And we have the minimum content of that in woody biomass, as I mentioned in the earlier part of this lecture. And larger content of ash are found in the non-woody agriculture and waste biomass. Concerning agriculture crops, the content of ash is related to that fertilizers are used for cultivating the agriculture waste, which leads to that we get higher content of inorganic compounds. On this slide you see different percentage of ash in different biomass assortments. In woody biomass it's quite low, between 1.5 up to 5% of dry matter, which DM means here. Straw have a little bit higher concentration of ash, as I mentioned. Peat are in the same range, 0.5 up to 6%. While waste then can have higher concentrations of ash, depending on which kind of waste we are considering. There are four characteristic densities: true apparent biomass, growth, and bulk densities. Bulk volume or bulk density include interstitial volume between the particles. So when you, for example, transport pellets, you often define the bulk volume when you transport it, which are quite important then. The heating value is defined as the energy content or heat which are released when the fuel is combusted in air. And the units of that are megajoule per kilogram when you have a solid or liquid fuel. You can also define it based on dry matter of kilogram when you have a solid fuel. When you have gaseous fuels, you used to define it as in megajoule per normal cubic meter, where the normal temperature and pressure is 273.15 Kelvin, that is 0 degrees of Celsius, and the pressure is 1 atmosphere or 101.32 kilopascal. There are two different kind of heating values. First, we have the higher heating value, which is the amount of heat released when all the fuel's evaporated moisture has been condensed. So here we have the heat of the vaporization included. The lower heating value is the amount of heat released when all the fuel's moisture is in the evaporative phase, where the heat of vaporization is excluded. In the energy industry, mostly the lower heating value is used, which is due to that the heat of vaporization is often not used. If you have condensation of the steam in the flue gas and use or reuse the heat again in the steam, then the higher heating value is interesting. And when you use biomass with a large amount of moisture in the fuel, you often have flue gas condensation. So flue gas condensation has been invested in many heating plants when you use biomass as fuel. Here you see an equation where you can calculate the lower heating value if you know the higher heating value or the diverse. Then you have to consider both the hydrogen mass fraction in the fuel, as the hydrogen in the fuel is converted to water when the hydrogen in the fuel is oxidized. And you also have to consider the fuel moisture in the fuel, as that is vaporized. You also have the heat of vaporization here for water being 2.44 megajoule per kilogram at 25 degrees of Celsius. Here you see different data for lower heating values. For oil, it's quite high. It's slightly more than 40 megajoule per kilogram. For natural gas, you have 31 to 42 megajoule per normal cubic meter. For coal, it's a bit lower compared to oil, 25 to 30 megajoule per kilogram. This number here for woody biomass is raw biomass then, where you have moisture content around 50%. Then you have a lower heating value of only 7 to 9 megajoule per kilogram. For dry biomass, you have lower heating value almost up to 20 megajoule per kilogram. For municipal solid waste, it can vary between 8 and 15 megajoule per kilogram, depending on the moisture content. So that was the last slide on this section. Concerning literature, you can have a look to Prabir Basu, Biomass Gasification and Pyrolysis, Practical Design and Theory, which covers the whole biomass block in this course. So you have 2 chapters covering biomass origin and characterization, 2 other chapters for basic conversion technologies and thermal conversion of biomass, and finally also biofuels. Thank you very much.